See, it's like the problem comes in with the projector. Presenting and displaying at the same time is where the issue is. That we need to find a solution for. Can we test this?
Yep.
Are you streaming now? Keep the cuss words at a minimum.
Me?
Yep. Directed towards me.
It's not you, it's software, man. You didn't write this stuff. Yeah, like switching between windows is like not a good plan.
I mean, the other thing is just to not duplicate, and then you'd have to have your notes on a different device. And then you always just focus on the screen that's in front of you.
Yeah.
Option? No?
Not with this presentation software. 'Cause my notes are on this. This is a browser window, right?
Scroll to change it here.
Yeah. Definitely gonna step on that and yank it out of the wall. Need a longer cord.
A longer cord though because of the length that's in the ceiling.
Yeah.
It starts to garble the image.
Okay, you need a longer cord and a repeater.
Seconds.
10-second delay. You got me on the delay so you can delete me.
No, it's so the video is going to be in sync with the audio, but it's all 10-second delay. I don't know if you can tighten up that delay at all.
It's fine.
The online LIS.
I'll forward it out right now.
Nope.
Stream for Steve Hall's Forward Thinking on Spring Cloud, Netflix, OSS can be found by navigating to
Can I swing that monitor closer?
you can move over here too.
Yeah, I'll probably just move over there.
Trip yourself with all this stuff. The stream for Steve Hall's Forward Thinking on Spring Cloud, Netflix,
course.
OSS can be
If I
found
move
by
over there, then I'm
navigating to
stepping
yeah,
over the... closer the better. So I can actually see what tab I'm clicking on.
That's as tight as I can, close as I can go.
Okay.
Got this?
Hmm?
Got this?
The window switching may be a challenge. Wasn't anticipating that.
This is always going to be what you're showing.
Yep.
You know, the sub windows, maybe you just bypass some of those, you know, like the pop-ups thing in the IDE. You may have to just not show those if you don't want to have to flip to those.
Yeah, the switching back and forth.
And maybe, how often are you planning on switching back and forth?
Quite a bit.
Or you just do the window.
I mean, in
Or
the
you
demo,
just share the window and you don't see the right side of it because it's shifted for whatever reason.
But that'd be the whole thing. And if you can't see a third of the screen, people would just say,
yeah.
I would do some Googling on Optima offset screen.
Well, the reality is that the only people really going to be affected are the ones that are viewing it remotely.
But you're not gonna really know how many that is.
I will.
He will.
How's it going?
Some Breaking Bad. Okay.
What made you venture into Netflix OSS?
I started looking at Netflix OSS about 2.5 years ago. Netflix had open sourced it starting in 2013, and microservices were just starting to get hot. And Netflix was kind of the poster child of doing microservices in the cloud.
One of the few that actually posted
Yeah, Twitter's open sourced some of their stuff, and LinkedIn open sourced Apache Kafka, their backend bus. wait another minute for stragglers and then I'll get started.
Three people streaming. Wow. Where's the camera? Oh.
He's one of them, this PC is one of them. And you probably. Yeah, where's the camera, right? Oh, cool. Hi, Eric. He's waving at his monitor. All right, I'm gonna get started. So my talk is Spring Cloud Netflix OSS. This is going to be a Java heavy talk, but I think the concepts we'll go over in regard to distributed computing and distributed systems are something that kind of apply to any stack. So thanks to Mr. Mansky and Greg for fighting with the projector and remote sharing presentation stuff. So I'd have been lost without them. If you don't know me, I'm Steve. Been doing Java for a long time. Been consulting for about 10 years. Centera the past 5. You can find me on the usual social network stuff. So Netflix. So who remembers the BMG music group? You get 12 CDs for $1. 2 people, awesome. 3. So what happened to BMG Music Group? Well, like Napster happened, right? And consumer broadband happened. And digital music happened, Spotify and all that, right? So in 2009 they shut down the club. That seems a little late, but and BMG Music, the company, was the 5th largest music company in the world. And around that time they got broke up, sold to Sony Music, Universal. So that company obviously did not adapt to consumer broadband and those types of changes in the marketplace. But Netflix, around that same time, had a very similar model, if you remember. You basically go on their site and you set up your DVD queue, and they snail mail you a DVD, and you watch it and you put it back in the box, and they snail mail it back to them, and then you get the next DVD in your queue, right? But they did some things, obviously, to adapt to a changing marketplace and new technology. The first streaming went live in 2007. 2009, they began their cloud conversion from their data center after they decided that they didn't want to be in the data center building business. Today, they're almost a $7 billion company, global in nature. They're producing international content, trying to go live in Asia. They went live in Europe last year, and they have millions and millions of customers. So what are some of the factors that enable Netflix to move fast in the marketplace? Netflix has been very open about how they do business and the technologies they use. Their architect, or former architect, Adrian Cockcroft, has been on the speaking tour scene for about 3 years, talking about all the things they do at Netflix. So we're going to go over some of those things. So their architecture, they're on Amazon Web Services. A way that makes them agile in the marketplace is obviously they kind of treat infrastructure as utility like water. It's an API call away, right? It's cloud native. They also have a large suite of Java-based microservices, around 700 different services they deploy on thousands and thousands of AWS EC2 instances. And they've really greased the wheels for developers and teams to execute by implementing continuous delivery pipelines and building their own sort of continuous deployment tools for the cloud and AWS. So it's not just about technology, it's about culture, right? Netflix has a culture of freedom and responsibility. Amazon talks about you write it, you own it, you run it, right? So teams are basically responsible for the software that they run. So Melvin Conway had this idea back in the 60s, and he said, organizations which design systems are constrained to produce designs which are copies of the communication structure of the organization. You think about like how ERP systems are structured from a module perspective. It totally represents how typical businesses are structured from a department level. And the interfaces between those modules are exactly how the business operates, right? Accounts payable just dumps their receivables over the wall, and GL picks it up, right? So if you want to go with a microservice architecture, and you want to organize your teams in a way that they'll be productive, you want to organize around products instead of projects, right? So you basically build a team to run a feature of your system, or a microservice, or a suite of microservices. And that's how Amazon has, and Netflix have both organized how they execute. So we mentioned microservices. So this is Adrian Cockcroft's definition: lightweight, loosely coupled, service-oriented architecture with bounded context. So there's a couple things in that. One is this first part: lightweight, loosely coupled, service-oriented architecture. So he's really saying microservices are part of SOA, but they're not traditional SOA of 10 years ago, where you have a big enterprise service bus that's got all kinds of logic about how to transform data and workflows about how to route data. He's saying basically you want thin pipes for your transports, something like REST with JSON. And then bounded context is this idea from Eric Evans' book, Domain-Driven Design. And really a bounded context is sort of a encapsulation of all the technology or all the things required to deliver a feature of the application or a context in the application. So what Adrian is saying is we want basically some sort of lightweight transport protocol. We want to organize our processes around business value and bounded context. And of course, Martin Fowler, everybody knows who Martin is. He describes it as smart endpoints, dumb pipes, which is kind of a Unix command line tool idea, where you can pipe multiple commands from a Unix command line together in a stream and get the results you want. So you can do PS pipe to grep with a search string, and you can search all the processes on the stream. But PS and grep are two different processes or services, you could say, that produce an output that is a combination of both of their features. So a lot of people ask, well, what does micro really mean? How big? I've heard people say, well, it should fit in a developer's head. Well, what does that really mean? Or 200 lines of code. Well, 200 lines of code in what language, right? 200 lines of Perl could be 500 lines of Java, right? But I think what they're trying to get at is basically the developer cognitive load to understand what this microservices is doing should be small. It should not take somebody 2 weeks to come up to speed on a microservice, right? You should sit down and a couple hours to understand what the heck's going on. So why microservices? Kind of touched on some of that earlier. So obviously if you have your monolith broken up into small chunks, you can scale each chunk individually. So for example, if you had like a time tracking system in payroll, obviously your time entry by human behavior is going to be whenever your time is due, right? It's going to be Friday at 3 to 4. So you can scale up that time entry piece separately from the rest of the system. Agility and speed to market. obviously is very important these days. And microservices, really, because they can be deployed independently, because they're smaller and cognitive load is lower, they can increase your throughput and speed to market. We kind of talked about Conway's Law and team structure, organization around basically organized teams that own the entire that microservice or that business function. And because microservices can be deployed as separate processes, you can pick whatever tool is best for the job, right? So if you're, if you're say streaming some kind of content into a big data type system, you can use big data tools for that. Or if you're building RESTful web services, you use .NET or Java or whatever. But because they're deployed differently, each team can kind of pick what is the appropriate technology for that team. So yay, let's do microservices, right? Microservices require a certain degree of operational maturity. Obviously, those things are, infrastructure automation. You can't be waiting 6 months for a machine or a year and a half for a machine. Your DevOps pipeline needs to be in place. You need to make production deployments boring, as Jez Humble says. And you need some kind of monitoring in this at the bare minimum, because you're going from a monolith type application where everything is deployed in one huge package that you can plug in a debugging tool and see what's going on, to an architecture where you have many processes distributed. So debugging that kind of infrastructure can be more difficult because it is distributed. Martin Fowler talks about this on a blog, which I, of course, stole his image. I'll give him credit down here. So Martin Fowler says, okay, if you have a less complex application, you have a small team, you're not having issues scaling your team to get things done, it's probably not worth the investment that we just talked about in going to a microservices style architecture. But as the complexity of the system increases, as the monolith gets larger, there's an inflection point where you want to start looking at microservices, because if you've got a huge monolithic application, and say you've got 5 Scrum teams trying to iterate on that, say you have a critical bug in one of your go lives, then everything stops, right? That monolith can't go into production. So all the work that all the other teams did is backed up in your pipeline, waiting for that one team's bug to be fixed. Where in a microservice architecture, each team is basically responsible for their delivery, right? You want each of the microservices to be able to be deployed and delivered independently. And if you get into a situation where you're deploying microservices and they have to be deployed sequentially, or there's some dependency between the microservices, then all you've really done is build a distributed monolith, right? You want each of those services to be deployable independently. All right, so things to consider when you're building a microservice architecture. If I've got many microservices and I have them deployed in, say, a cloud infrastructure across many instances, and I want to do like feature toggles or some kind of configuration, how do I do that? Again, if I'm in microservices type architecture, how do the services find each other? And how will my web browser or my phone apps talk to these services? I don't want my phone apps trying to talk to hundreds of different servers at the same time, right? That would be terrible. And what happens when things fail? Because we're in a distributed system, now we have network involved, a lot of different things that can fail. And how will we monitor this? right? We need some sort of monitoring. So Netflix OSS can help with this. From an overall project perspective, there's a whole slew of tools. What we'll talk about today is some of these runtime services and some of the reliability and insight services that you can use. So Netflix OSS was open sourced starting in 2013. It won the one of the JAX awards, which is a Java conference award. That's a pretty big accomplishment. And Spring Cloud is basically a Spring Boot-based abstraction layer over Netflix OSS and other cloud-based solutions like Console, which is from the guys that do Docker, and Kubernetes, which is from Google. All these are sort of service discovery type tools, but basically with Spring Cloud you can say, I want to enable service discovery, and based on what library is available, it'll pick up and configure that. So your app can do service discovery. All right, so I'm going to jump into a demo here. So we got Eclipse. Let's see. Bear with me, I'm getting used to this monitor setup. All right, so the guys at Spring have the site called Spring Initializer. What it basically does is it'll build you a Spring Boot app based on the dependencies that you select on this page, which is pretty cool. In the past, there's been a lot of pain and anger and agony around trying to spin up Spring Boot or Spring apps in general. So I'm going to just grab web dependency, the config client, and the actuator. And I'm going to call this guy, greeting service. I get that right? So basically downloads me a zip file. You guys can't see what's going on here, can you? That's fine. Where the heck is my mouse? So I'm just unzipping this thing so I can import it into Eclipse. All right. So back to my Eclipse. You guys see that? Now I gotta switch the windows, don't I? You guys can see that. Just trying to get the window sharing right for the people online. All right. So I'm going to import this guy. need a faster machine. All right. So the initializer built me basically a Java project. So this is basically a simple Spring Boot app. I can say REST controller. Come on, autocomplete. I definitely need a faster machine. All right, REST controller. So what I want to do is basically show you how the configuration works. So I'm going to have a private string greeting. Yep. And then I'm going to have a plus mapping to just going to be a public method. We're just going to return the greeting. What's that? Yep. That's just an annotation. So, yeah. Ah, thank you. Grading? You don't like that? All right, so why won't this compile? What's that? Oh, right. Why won't this work? Right, this can't be public. All right. So I can just run this, hopefully. All right. Yep. Okay, join me, switch window, that one. So that works. Yay. Hello world works. It's a miracle. Oh, this window switching is killing me. Nope. We tried that for about an hour. So I'm going to spend most of my time here, like, switching between windows. So if I put this refresh scope annotation on here, I can basically say, even though this controller, is a singleton in Spring, I can send a request to basically reinitialize the controller and the value of greeting. If I can type and see what I'm typing, that'd be awesome. So I'm going to have a property for my greeting service called greeting. And that's going to be actually in GitHub. So what I need to do now is go out to Spring Initializer again. Download the config server after I switch windows. Yay. So I want a config server. I do not want all this though. Right. But I don't want the greeting service. So now I'm just unzipping that. All right. Switch windows. So this is going to create a Spring config server. All I need to do is say yeah. Definitely need to. All right, so I need to set what port my config server is at. And I need to tell it where to look for the properties. So we can do that in this application property. So we're going to run this server on 888. And I have a GitHub repo out here with all the properties for all the services I'm going to be running. So I can just run that. So now if I stop the greeting service and restart it, because we added those annotations for the config client and the value. Yeah. I need $1. You're right. Ah, thank you. So I restart that? No. Yes. Doesn't like reading, of course. Well, follows fails. I swear this worked before. So what do I have wrong here? Oh, I know what it is. I did not bootstrap my properties. So I need to add a property that tells my REST service where to go look for the config server. And that's what I have not done. So typically your properties are in an application properties in Spring, but Spring Boot will look for a properties file called Bootstrap, which will load properties on basically booting of the container. So we want our properties that tell it where the config server is. Oh, I changed the wrong one, guys. In the greeting service, this is the one I want to change. All right, so this is saying, I'm the greeting service, so use the properties in GitHub for the greeting service. And the greeting service is on localhost 888, right? All right, now it's happy. Switch windows. All right, so when we run a Postman, we should see properties from heck's my mouse? My machine is so slow. Running on 2010. All right, so these properties are actually in a properties file on GitHub, which that's a fine greeting and all, but you know, maybe we need to add a little more oomph behind it, right? So if you read Reddit, you know, exclamation marks on Reddit are a way to add emphasis, right? So let's do that, because I want to show you a feature of the config server and the refresh scope. All right. Switch windows. So here's my greeting service properties. Here's a message we saw. So of course we need to add some exclamation points, right? Commit that. Now if I go back into Postman and switch windows, ooh, where's my mouse? Go to Postman and we run this. We see the same message. But if we look at the config server, it already knows that our message has changed, right? So what we can do is basically post to our greeting service this refresh command to have it refresh the properties. So what you can do with Spring Cloud is set up a bus that backs this refresh command with something like Kafka or any basically MQ-based or message-based broker, so that all of your microservices that are listening for the refresh will get refreshed. I don't have that set up. I'm just refreshing this one instance. But it tells me, okay, I updated the greeting. So now if we go back, yay, hello Centera with exclamation points. All right, so hello world's great and all, but we need something a little more substantial. So I'm going to go out to, I'm just going to do this without sharing this. Well, I can't really see the monitor, can I? All right. So I want to basically create a more robust kind of web app. So I want to use H2, which is an embedded database. I'm going to use JPA, which is a Java standard persistence mapping framework. REST repositories, which will expose my, basically expose my entities that are managed by my persistence framework through a REST endpoint. I want a config client so I can talk to the config server. Eureka, which we'll use later. And actuator. This thing is going to be called what? Menu. because we're going to create a little like restaurant-like app that just belches out a menu. So I download that guy. To Eclipse. So again, this generated me a new Spring Boot app. So instead of me floundering around, just going to grab what I need. All right, so what do we have here? So basically an entity that'll be mapped to a table called menu item. It has an ID and a name. ID will be a generated value. Then I have a Spring Data repository that will give me basically all the CRUD and Finder operations based on the attributes of my entity, given this extension of the interface. I'm implementing command line runner so that when my app starts, it runs this run method, which I'm going to basically stream over my menu items and create new instances of menu and stuff them in the repo. And then I'm just going to belch out what we created. And that I'm going to save for later. All right, so let's just see if this actually works. So if I go back to Postman, all right. Forgot one thing. I forgot to set the Bootstrap properties again. So here I'm saying, I am the menu service. I'm going to run on, not on 888, I'm going to run on 8001. Did I stop that guy? No. All right, so I'm saying I'm going to get the menu items by page with a size of 2. What have I forgot? So this is 8,000, right? Menu service, 8,000. So we see our menu being created here. Oh, it's on 8080. That's why. Why is it on 8080? Oh, I know. I'm getting ahead of myself. All right, so we go back to Postman. Share window. Just need to switch this to 8080. So we get how to US based output. So we can basically navigate from the metadata in the how to US output to our specific items like our taco. And it also gives us metadata about what we can navigate to, so we can go to the next page or the first page. Basically with annotations, which I think is pretty cool. So one of the things we talked about in the slide is how will services discover each other. So the next thing I'm going to do is set up a discovery service called Eureka from Netflix and show how that works with our service here. So I want to name this what? This is the check everything we need. And config client also. Actually, I'm going to call this something different. This could be, so again, just working on importing this. So our Eureka server is basically going to be a place where all of our services basically register themselves. Basically, we just turn it on by saying enable, what is it? Eureka server, right? And of course, we need a our bootstrap.properties. So again, we're just, like we did before, naming and what port. Yep. So now if I go back to my menu service, uncomment this annotation, I'm going to restart this guy, the menu service. So now if I go out to web browser, yeah. So this is menu service. Did Eureka not start? Oh, there's one running. I stopped the wrong thing. All right, so what do we have running? Greetings, config. All right. All right. All right, that's happy. And it registered. All right. Now, switch. So now we see our menu service registered with Eureka. So in this environment, if we had, say, 10 instances of the menu service up, we would see 10 different nodes on different machines. So when a client wants to talk to the menu service, it can ask Eureka, hey, do you have an instance of the menu service? It'll give it back one of these nodes. Another thing Eureka does is it does health checks against the services. So if your service goes down and another client calls Eureka for your service, if one of your nodes is down, it'll drop it out of this list. So it's a mechanism for kind of reliability of service discovery and service discovery clients. Another thing this is good for is for continuous delivery and deployment in this environment. So you could bring up, say you're doing like a red, black, or whatever type of color deployment you call it, where you bring up a whole suite of infrastructure for a new version of your app. You could bring it up basically out of service in Eureka. And when you want to cut over from the old version to the new version, you can use the REST API in Eureka to basically turn off all the old version, enable all the new version, and then your traffic just gets automatically routed to the new version of your service. So what are we doing next? So we kind of talked about if you're in a microservice environment and you have many instances of your service, how will clients talk to this service? So what I'd like to stand up now is an API gateway using Netflix Zool. So what an API gateway does is it basically just handles routing to all your backend services. So Zool will use Eureka to figure out what services are available and basically route them for requests. Just give me a second. So I want client config. I think my biggest problem I have is I can't see the damn mouse pointer. All right. I think with this presentation stuff running on here and my little bitty machine, all this stuff is just eating my CPU. So all we need to do is enable this guy. Oops. Where's my mouse? All right. Again, just name the service pointed at the config server. And we'll try and run one more thing here before my machine totally crashes. Yeah, my machine's just not handling the presentation and all these processes. So something didn't come up clean. The demo demons are after me today. All right, well, my machine is just not cooperating here, to say the least. Yeah. So what the API gateway will do is basically take your service name. So it'll take the service name out of Eureka and route your request through to your service. So, for example, you can hit the API gateway / menu service / the menu item service I had running, and it'll route those requests through and basically return the same content with the routed URLs in the HowDOS content. So right now I'm trying to see what I have on the screen here, and the rendering is so slow I can't find my cursor. So I need to see why the API gateway didn't come up. So I think I'm going to give up on that. Back to my slides. All right, so we got through some of these things. It's after 1, so I'm going to wrap it up. So acknowledgements. Obviously, I mentioned Adrian Cocroft and Martin Fowler. Sam Newman's another guy from ThoughtWorks that has a book and talks a lot about microservices. And Josh Long and Matt Stein are guys from Pivotal that are very involved in the Spring Cloud and microservices space. One thing that's going on is Matt Stein has started a .NET port of some of these Netflix OSS libraries. So things like Eureka and the config service and other things will soon be available as Netflix OSS in .NET. So questions?
Does the Eureka service, I know that if you hit it, you could get any of those services. Does it try and do anything more than load or health check or do a load balance?
So the Zool API gateway has a built-in client-side load balancer called Ribbon. And what that'll do is Ribbon talks to Eureka to get its list of servers, and it has built-in load balancing rules. So if you're on AWS and you're in a particular zone, because their regions are divided up into zones or data centers, it knows what zone it's running on, and it'll look at the metadata from Eureka about what servers or services are in what zones, and it'll route traffic based on those zones. It'll also route traffic on response time. So if one of your instances in that zone is running slow, it'll prefer faster instances. Or if an entire zone is down, it'll reroute traffic out of a zone to services that are running in a different zone. Zool also has built-in circuit breakers with Hystrix. So the circuit breaker pattern is basically over a time series of, say, 5 seconds, if 50% of the requests fail, it'll open the circuit. And by opening the circuit, you can either configure it to basically error, or you can configure a fallback. So for example, in the Netflix case, if there was a request for, movie suggestions for Andy, and it failed, the fallback may be, well, give me the, top 10 movies in the past month. So they're returning something, but it's not exactly what you want. So the user doesn't really see it. It's just a fallback mechanism. So after 30 seconds, Hystrix will basically go into a state where it's half open. So when it's half open, requests can go through it, but if one of the requests fails when it's half open, it goes back to open completely, back to the fallback method. So that, basically what that does is it provides you a mechanism where you can fail fast. Because what you don't want is, for example, something that's not guarded by a circuit breaker to basically sit for, say, your default timeout, like 30 seconds or a minute, and then eventually all of your request threads on that node get stuck sitting there waiting for that one request to go through. Or get stuck waiting that 30 seconds, and that because those threads have backed up, that back pressure can flow through your whole system to a point where, you know, it's unresponsive because everything's backed up waiting for all those requests. So failing fast or failing back to a default response provides you a lot of reliability. Yeah, you definitely want it horizontally scaled, and I believe Netflix runs a cluster of API gateways per client type, so they'll have like a web client or HTML5 type client gateway. They'll have one for like mobile, and others for like all the other sort of IoT console type devices like your PlayStations and your whatever else consoles you can think of, right? And I think the reason they run the API gateways per client type is that they're probably doing different authentication and different transformation of the data. For example, your HTML5 client may want a HotEOS based response with all the metadata about how it can navigate, but a console probably doesn't care about that. The navigation's already built into the console, right? Just as an example. And different authentication schemes too, because, for example, if you're on like an Xbox, obviously you're authenticating through some kind of Microsoft service. So when you go to Netflix, there's got to be some kind of federated identity authentication going on between Microsoft and Netflix, which is only for that particular case where you're on a device that's really managed by Microsoft versus a HTML client where you're doing the authentication through Netflix or some OAuth type authentication scheme. Anybody else? Well, thanks for your time and all my muttering through all this. Have a good one.
One of the things we could have done is brought up another monitor, and then had Cap been able to share, and then we could have just.
Yeah, like this is the one that couldn't even like render my mouse. I was like,
Yeah, 'cause that's not gonna be fast enough. That's
No.
won't you join me? What if you would have had a secondary monitor that you would have been able to use?
You were just working in that little box?
no. It was full screen on here, but it was rendering so slow on here I couldn't like see the mouse. I'd move the mouse or drop a window down and it'd be like 10 seconds later it would do my user event.
Oh, because that's through the join me?
Yeah.
Oh god, that must have sucked.
Yeah,
'cause
that's
really
what I
this
was like,
setup's never used.
oh my God.
Yeah.
I didn't get through half the stuff I wanted to. Oh well, hopefully I made some sense.